Okay, today we will be learning how to graph sine and cosine graphs. Here is the original sine graph, y equals sine of x. If you take a look at it, it's just a graph that oscillates up and down. And then if you look at the middle part of it, that is in red, that is what we're going to focus on the most. Try to remember that the beginning of that red part starts here, and then it goes up, and then down, and then up, and ends here. All right, that's one cycle, one period of a sine graph. Try to remember what that looks like. Here is the cosine graph. Notice it looks almost identical to the sine graph. It just oscillates up and down, but then let's focus on the red part of it. With the cosine graph, it does start up here, and then it goes down, and then up, and then ends here. Kind of like a parabola. Try to think of it, cosine graphs that way as well, like parabolas. Here are the general equations of sine and cosine graphs. They look pretty complicated, but each individual part is not too bad. The top equation is when you're dealing with degrees. Notice the theta in it right here. And then the bottom equation is for radians, and that's represented with the x. Okay, let's look at the parts. The V stands for vertical shift. That's just how much the graph goes up or down. The A stands for the amplitude. That's how fat the waves are. Are they going to be big waves or skinny waves? The P is the period. That's one cycle of the graph. It's related to the 2 pi over p. We'll look at that in a little bit. And then the H is the horizontal shift. How much the graph shifts left or right. All right, let's do an example. Let's graph this sine graph. There's a few things you should refer to on this page. At the very top, I have a general equation of a cosine graph, and on the top right is the general equation of a sine graph. In this case, our graph is going to look like the one on the top right, the sine graph, because we are dealing with sine. All right, first thing we look at is this, the 2. It was the V, the vertical shift, how much the graph goes up and down. In this case, it goes up 2. To help us do that, we're going to go ahead and draw a dotted line at 2. The next thing we're going to look at is the 6, the amplitude. Remember, that's how tall the graph goes and how low the graph goes. So from the 2, we're going to go up 6 and down 6. That's how wide our graph is going to be. We're going to skip that 30 for now and then jump straight to the 5, the horizontal shift. In this case, it is 5 degrees, but we're going to go to the left. There. It's the middle dotted line where -5 is. It's this point right here that we're plotting. All right, the next plot we have to point, the next point we have to plot is this one over here. In order to get that point, we're going to now use that 30 degrees. I mean the 30 that was there. Remember the P, the period, had a special little formula on the side, this formula, the 360 over P. All you have to do is plug in the 30 into the P to get 360 divided by 30, and it does give you 12. And the 12 is what helps us find the last point in the graph, this one up here. Okay, from your beginning point, you're going to count 12 units down to the right. And there, it should end up at 7. All right, from there, we're going to go ahead and find the midpoint. To find the midpoint, you just add the beginning to the end and then divide it by 2. So in this case, -5 plus 7 divided by 2 gives us 1. The next point we're going to graph is this one up here. It's the middle of these 2 points. So to find the middle again, we add -5 plus 1 divided by 2, and that gives us -2. There it is. And then the last one we graph is this point, and it's in the middle of these 2. There it is. All right, now that all the pieces are there, let's go ahead and draw our sine graph. There it is. Okay, let's try another one, but this one, notice, is in radians mode. We know it's in radian because the top says radian, but also the x is being used. So now we have to think about radians. Also, we have to think about cosine and what a cosine graph looks like. Cosine graphs look like this, like a parabola. Okay, so just try to think that's what we're going to draw. First thing we look at is the v, -5. There it is. Up next is the 3. How far up it goes and how far down it goes. It goes up 3 units and down 3 units. We're going to skip this period for now and jump to the h, the horizontal shift. Notice that's how much it moves to the right or to the left. In this case, the plus pi makes us go to the left 1 pi. And if you guys notice here, I have changed all the numbers so that they're pi's instead of just regular numbers. All right, so we're going to do 1 pi to the left. And then it goes here. Now the reason why this one started at the top is because that's that point that we're graphing. To find this point, we now go back to the p, the period. Remember there was a side formula for the p. It was 2 pi over p. Plug in the 1/4 for p. Take that bottom fraction, flip it, and multiply it to the top. We should get 8. And that's how we find the last point. Use your beginning point and then count 8 units to the right, and you should end up there. The next point we graph is this bottom one. It is in between the first 2 points. So again, to find the middle of that, you just add the two numbers and divide it by 2. So a -1 plus 7 is 6 divided by 2 is 3. And that goes where the 3 is. And then to be more accurate, we're going to find this point and this point. This one is the middle of these two. And then this one is the middle of these two. And then we have our cosine graph. All right, let's do another example. Here we have a sine graph. It does say sine. So we're going to have a graph that looks like this. The 1 is the middle dotted line. The 5 is how much you go up and down. Up 5, down 5. This minus sign is going to make the graph look a little bit different, but we'll come back to that in just a little bit. Let's find the beginning point. That's the minus pi over 2. Remember, when it's a minus, we go to the right, and if it's a plus, you go to the left. So in this case, pi over 2, that's half of pi. There it is. I know I didn't change the units on the graph to be the pi's, but please know that they're supposed to be pi's. Okay. To find the last point, that's our p right here. Using the little side formula, 2 pi over p. Bring the fraction up, multiply by the reciprocal, and it gives you 5 pi. So from our first point, count 5 units to the right. And there should be the last point. All right, now let's focus on this minus sign that's right here. Our graph is no longer going to have this roller coaster up and down, but instead it's going to be reflected the other way. Okay, so we're going to find the middle point now, which is in the middle. But the next point, because of that minus sign, is not going to go on top, but it's going to go on the bottom. And then the other point on the other side, instead of going on the bottom, it's going to go on top. And here's how our sine graph is going to look like. Okay, it's reflected or flipped around just because of this negative. Here's another. This is in degrees. We know it's in degrees because it has the theta. We also know it's a cosine graph because it says cosine. So our graph should look like this. Okay, if you notice, there's a few pieces missing. The very first thing we are looking at is the V, the vertical shift, but there's no V. It's missing. The number in the very front is missing, which means that the V is 0, right in the middle. The amplitude, the A, is 2, so you go up 2 and down 2. The beginning point, this point right here, is the horizontal shift. The -5, which goes in the other direction, so +5. And then the last point is from the P. Notice the P is not there. That doesn't mean it's 0. It does mean it is 1. So using that little side formula, 360 divided by 1 is 360. So from the beginning point, we have to go 360 units to the right, which is off the charts, way off the charts. But if I were to write the point, it would be 365, comma 2. So it's way off the charts. And then, of course, we have to find the middle point, and then these 2 points right here, but they're also off the charts. So that's what the graph would look like. It's just too far off for us to see it all. But you get the gist. The point of this example is that it was missing a V and a P. The V was 0, but the P was 1. And here we have the last example for the day. This is a sine graph. Should look like this. Let's start off by graphing the V, the 8. But notice the amplitude is missing. The A. It's actually 1. So when that's missing, it's a 1, which means we're going to go up 1 and down 1. Our beginning point is plus pi, so we're going to go to the left one. There it is. And then we're also missing a P, this number, which when it's not there is also a 1. So 2 pi over 1, which is 2 pi. So from the beginning, we're going to count 2 pi's to the right. That's where it ends up. Then we have to find the middle point and then graph it. And there it is, graphing sine and cosine graphs.